Hello, Physical Science. This is Mr. B, and we are continuing on with Newton's first and second laws of motion. Again, remember the first law of motion is an object in motion tends to stay in motion. An object at rest tends to stay at rest unless they're acted upon by an unbalanced force. So now we're going to take a look at Newton's second law. And what Newton's second law does is it relates force, mass, and acceleration. So what is stated in Newton's second law is that the acceleration of an object is equal to, so we're going to have a little equation here, the net force acting on it divided by the object's mass. So Newton's second law, again, it relates all of these three together in a simple equation that we can use easily to solve for acceleration, net force, or mass. So the acceleration of an object is directly proportional to the net force acting on it. So again, how fast something is going to speed up, how fast it's going to change its velocity, is dependent upon the net force that's acted on it. And it is also dependent upon the object's mass. So again, usually a larger mass could mean more acceleration, or probably even probably a less acceleration, because it's going to be harder to get that larger mass moving. And our definition for mass is the measure of the inertia of an object. So remember, inertia is the tendency of an object to resist motion. So how much an object wants to resist motion will be what its mass is. And hopefully that makes sense. And again, I'll probably have to explain that a little more, but mass is directly related to your ability to resist motion, and we usually think your ability to resist motion would probably mean you have a little bit more size just in general to you. And then here is our equation, so I would definitely write this equation down, that acceleration equals net force over mass. We will be working with this, and we'll actually go through a sample problem here in a second. So acceleration of an object, just again to make some more rules here for Newton's second law, is always in the same direction as the net force, and when a net force acts in the direction opposite to the object's motion, the force is going to produce a deceleration, because it's going to be slowing down when the force is going against the object's motion. And so, so here's our example here for Newton's second law. So an automobile with a mass of 1,000 kilograms accelerates when the traffic light turns green. If the net force of the car is 4,000 newtons, what is the car's acceleration? So after we read this problem, we follow the first step. What information are we given? And we are given that the mass is 1,000 kilograms and the force is 4,000 newtons in the forward direction. Again, it's pretty easy to see. We can go right here. Again, 1,000 kilograms for the mass. Net force is 4,000 newtons. Again, so now, again, it's pretty simple to figure out what we were given. And so now our next is what unknown are we trying to calculate, and then what formula contains the given quantities. So we're trying to figure out what acceleration is, and we've only been given one equation, so it's going to be pretty simple to figure out what equation we're going to need. Acceleration equals net force divided by mass. Acceleration, or A, equals F over m. And so now we're going to just plug it in. And 4,000 newtons over 1,000 kilograms, and yada yada yada. They can get rid of all these zeros, so it's just 4 newtons over kilograms, and then a kilogram. If you remember, going back to our first video for this chapter, a newton is equal to kilograms per meters per second squared. So the 2 kilograms are going to cancel out, so that's how we get acceleration equals 4 meters per second squared. And we will go over more examples in class to make sure we really understand how to cancel out those values there. So our acceleration of our car is 4 meters per second squared in the forward direction, because remember, acceleration has the direction of motion as well. So we got to look back, is our answer reasonable? And we say powerful sports cars can accelerate at 6 meters per second squared or more, thus a smaller seems to be reasonable. And so for our sample problem, which you can solve for extra credit points if you put the answer on the top of your quiz below the name, a boy pushes forward a cart of groceries with a total mass of 40 kilograms. What is the acceleration of the cart if the net force acting on it is 60 newtons? So if you solve that problem, then you can write it at the top of your quiz to get some extra credit points. And just to add some more, again, more supporting information here for Newton's second law of motion. Acceleration depends directly on force and inversely on mass. So the same force causes the single cart to accelerate 8 times faster than the chain of 8 carts. So that means if I push this cart, this one single cart, at a constant force, and I push these 8 carts at that same constant force, the acceleration of this cart is going to be 8 times faster because there's that much less mass. So less mass means the greater the acceleration that you're going to have. And maybe when some of you making those balloon cars, a lot of you said that you try to make it a little more lightweight, so that's where it's going to have less mass, so you could have had a little bit greater of an acceleration there. So that's going to be it for this first part. We'll break Newton's second law up, and we'll explain a little bit more with that tomorrow. So let me know if you have any questions.